Self-consistency prompting asks the AI to verify its own answers, check for contradictions, and validate its reasoning. It's a simple idea that gives you a real boost in accuracy. Instead of trusting a single-shot answer, you tell the model to solve the problem and then double-check itself. Look at this example. We ask for the final price of a $100 item after 20% off, then another 10% off. But we don't stop at the answer. We tell it to verify by working backwards, and if there's a discrepancy, find the error and fix it. That extra step catches mistakes the model would otherwise hand you with full confidence. Self-consistency turns single-shot answers into validated conclusions. There are 4 core techniques you can mix and match. The first is verify by reversal. Solve the problem, then reverse the calculation and check that both methods agree. The second is multiple approaches. Ask the model to solve the same problem 3 different ways, and if they don't match, figure out which one is right. The third is sanity checks. After calculating, ask whether the answer makes intuitive sense and falls in a reasonable range. And the fourth is explicit validation. Have the model state its answer, list 3 ways to verify it, and then actually run those verifications. Each technique forces the model to confront its own work from a fresh angle, which is exactly where errors get caught. Multiple approaches is worth seeing in action. Here, we calculate an 18% tip on an $85 bill, but 3 separate ways. Method 1 is the direct calculation. Method 2 breaks it into 10%, 5%, and 3%, and adds them up. Method 3 is an estimation check. 20% would be $17, so 18% should be slightly less. Then we ask the model to compare all 3 and tell us the correct tip. When independent paths converge on the same number, your confidence goes way up. When they don't, you've just found a mistake before it cost you. This is self-consistency doing real work on an everyday calculation. This technique isn't just for math, it works great for code too. Here we ask the model to write a palindrome checker, but we don't stop at the function. We hand it a test plan baked right into the prompt. Test race car, which should return true. Test hello, which should return false. Test a man, a plan, a canal, Panama, and ask whether it should even work with spaces and capitals. Test the empty string and decide what should happen. Then, if any test fails, fix the function. By making the model run its own answer against concrete cases, you catch edge case bugs before you ever paste the code into your project. Another angle is to ask for explicit confidence. Take this one. Is the capital of Australia Sydney or Canberra? We ask the model for its answer, a confidence level of high, medium, or low, why it chose that level, and what would increase its confidence. And we tell it that if confidence is low, it should note that it may be wrong. This is powerful because it surfaces uncertainty instead of hiding it. A confident wrong answer is dangerous, but an answer flagged as low confidence tells you exactly where to double-check. By the way, the capital is Canberra, not Sydney, which is exactly the kind of trap a confidence prompt helps you catch. Self-consistency even works on judgment calls, not just facts and math. Here we ask whether a startup should use microservices or a monolith. In Part 1, the model makes a recommendation with 3 supporting reasons. In Part 2, it argues the opposite position with 3 counter reasons. And in Part 3, given both perspectives, we ask whether the original recommendation still holds, and why or why not. This forces the model to challenge itself instead of just defending its first instinct. The result is a more balanced, better reasoned recommendation because it has already stress-tested its own opinion before handing it to you. That's the whole spirit of self-consistency applied to subjective questions. Now it's your turn to put it together. The lesson ends with a design challenge. Build a self-consistency prompt for analyzing whether a stock is overvalued. Think about what calculations should be performed, what sanity checks make sense, how contradictory signals should be handled, and which confidence indicators matter. Combine the techniques we covered: multiple methods, reasonableness checks, and explicit confidence. Remember, self-consistency turns single-shot answers into validated conclusions. Try this prompt yourself right now. Head to this lesson page on FreeAcademy.ai and run it in the interactive prompt playground, or just paste it into an AI assistant like ChatGPT or Claude and watch it check its own work. Experiment, tweak it, and see how much more reliable your answers become.